Hi everyone, this video is going to introduce you how to find the modulus of a complex number. As we know, a complex number we can represent as z equals to a plus bi, where the a is representing the real part and the bi representing the imaginary part. Alright, and the modulus is actually to find the length of the z, as the z can be represented in an Argand diagram where it's more or less the same as a Cartesian plane. But the x-axis is actually representing the real part and the y-axis representing the imaginary part. As I give you one example here. If let's say we have a z equals to a 4 minus 3i, means that in our Argand diagram, we are going to plot 4, negative 3 on our Argand diagram. That is real part is 4, so we have a 4 unit at the real part and a negative 3 at the imaginary part. Alright, so this is the point representing the 4, negative 3. If we're connecting this point with the origin, and this line is actually represent the complex number 4 minus 3i. And now we are going to find the length of the z, and this is going to write as a modulus of the z. So how to find the modulus of z? We're going to use the concept of a Pythagoras theorem, as this the right angle triangle. Okay, the height of the right angle triangle is 3 unit and the base is 4. So we want to find the length of the z. We can use the Pythagoras theorem, that is using the square root of 4 square plus 3 square. Alright, or you may write as negative 3 and square. You will back to the positive value. And finally, you have a 16 plus 9, which is a square root of them. Then it's a square root of 25. Okay, seems like the length of the z, or we say modulus of this complex number, is 5 unit. Alright, if we have given this complex number, and it's obviously this complex number haven't been simplified yet, because a simplified complex number will always in this form, z equals to a plus bi. So you can see that we need to simplify it first by multiplying by its conjugate. That is conjugate of the denominator. Yeah, the conjugate of the denominator, we just change one of the sign. Yeah? Normally I will change the sign in front of I, which I will find this conjugate as a negative 3 plus I, negative 3 plus I. So on top, we multiply negative 3 plus I, and the denominator also we multiply by negative 3 plus I. Then we expand it and simplify. After we expand, all right, we expand in this way. All right, 2 multiplied by negative 3, 2 multiplied by I, and then later I multiplied by negative 3, and I multiplied by I, you get I squared over here. The same thing goes with the denominator, you will get this. Alright, then after we have simplified, where the I squared, we have written it I squared as a negative 1. Alright, then we simplified it, you will get this. And you have to write it in the form of a plus bi. You couldn't leave it in this form. So to write it in the form of a plus bi, as this one, the simplified form, you have to write as a negative 7 over 10 as your a, and a negative 1 over 10i as your b. Okay, then we need to find its modulus, that is the length of the z. We can find by using the Pythagoras theorem, which is using the square root negative 7 over 10 square plus negative 1 over 10 square, taking the a square plus b square. This is your a, this is your b, and you simplified it. Alright, then you have a square root of 50 over 100. Further simplify, you get a third 1 over 2, And you can always simplify it as a 2 over 2. So this is the modulus of the complex number 2 plus I over negative 3 minus I. Thank you.